My name's Jessie Dawson. I'm a professor of stroke medicine here at the University of Glasgow. In the College of MBLS, we have a very strong interest in neurosciences, in research into stroke, and also into brain imaging. And we're very fortunate here at the Queen Elizabeth Hospital to have a 7 Tesla MRI scanner here on site.
I am Shajan Gunamony. I am the head of MRI RF engineering at the University of Glasgow, and I specialize in designing coils for ultra-high field MRI.
My name is David Porter and I'm a professor in MRI physics. We work on a 7 Tesla scanner, which has got a much higher spatial resolution than a conventional diagnostic scanner. The main objective of my group is to optimize that image quality to achieve the detail that we need for our clinical research, to look at the brain in particular in a lot more detail than is possible with standard imaging equipment. The impacts that we generate are enabling other researchers to kind of obtain greater information. For certain conditions, the extra detail that we can see at 7 Tesla is providing potentially diagnostic information which is not visible at 3T or 1.5T, which are the standard imaging field strengths. And so we're working in a few relevant areas for cognitive neuroscience. So one of them is improving the spatial resolution by introducing new ways of acquiring data, so new pulse sequences. We also have a program of motion correction. So one of the issues as we go to these extremely high field strengths of 7 Tesla, we are now in a position that we can acquire very high spatial resolution, but this means that the data we get are more sensitive to subject motion. This is one of the things we have to now address in some detail.
The impact from the hardware point of view is mainly about disseminating and commercial development of the technology that we develop here. This is already happening through the Living Lab project, so where we want to commercialize 5 different coils, basically 5 coils for different body parts. So for example, the current industry standard head coil has 8 transmit channels and 32 receive channels. The one we developed here has 8 transmit channels and 64 receive channels. So with this additional number of receive channels, we get, for example, up to 40 to 50% more signal to noise ratio in the cortical layers of the brain.
In more recent times, over the last sort of 5 to 6 years, in the field worldwide, there's great activity in trying to take the benefits of 7T MRI and apply them into clinical research and into clinical diagnostic practice. And so this is an exciting opportunity that was essentially the motivation for this Imaging Centre of Excellence where we're now sitting.
So one of the areas that was very exciting about this work in stroke recovery was that we worked in partnership with some preclinical and basic scientists who'd made some really novel discoveries about how the brain may recover after injury. And I think what was really nice was that these were ideas that I couldn't have come up with. These were novel scientific concepts that our colleagues had found, and we were able to work alongside them to help them translate that into clinical practice. Roughly half of people who present with a serious stroke will live with long-term disability. And that's proven a very difficult thing to treat. So what we've been trying to do is find ways that don't replace the physical therapy, because that will never happen, but make that physical therapy more effective. And some of our colleagues had found that by stimulating the vagus nerve in experimental animal models of stroke, you can actually improve the amount of recovery somebody gets from the physical therapy by enhancing the release of what we call neurotransmitters onto the surface of the brain.
So the Living Lab project is really enabling this kind of dissemination, commercialization of the technology that we develop here. That the coils are not just confined to Glasgow, it is enabling collaboration with other universities, it's enabling collaborations with other industry partners as well.
The great thing about it from my perspective is that it recognizes the network of disciplines that we need to achieve our goals in this area. It's a formal version of the kind of research network that we need. We need to include obviously the clinical specialists, we need to include the radiographers.
So it's been very, very, very powerful for me as a clinician to see the improvements that people have made at the individual level. So some of our participants in Glasgow who took part in the studies returned, for example, to playing the piano. One of our participants changed nappies on her grandchild for the first time, and we've heard from some of our American collaborators of people returning back to full-time employment, returning back to fishing, high-level sporting activities. So I think seeing how those numbers that we present on graphs actually translate to people on the ground and real people's lives has been hugely powerful.